This segment of code begins with an outer for loop, which we will track using the large red arrow on the left. The outer loop statement begins with a declaration of the variable x, which will be used to control this loop. X is given an initial value of 0. Let's place a graphic of this value here to help us keep track of the x value as we move through the outer and inner loops. The next part of the for statement is the constraint. In this example, we are told that the outer loop will continue to repeat so long as the value of x remains less than or equal to 4. The next part of this statement is called the iterator. This code tells us that the value of x will increase by 1 each time the outer loop is completed. After the statement is read, we enter into the body of the outer loop, and we are, in this example, immediately presented with the start of an inner or nested loop, which we will track using the blue arrow here. The inner for statement begins with a declaration of the variable y, the variable which will control the flow of the program throughout the inner loop. It too is given an initial value of 0, which we will highlight here to help track its value. Continuing to the constraint of the inner for loop, we again see that this loop will continue to repeat so long as the value of y remains less than or equal to 4. The last component of the inner for statement is the iterator, which tells us that y will increase by 1 each time the inner loop is repeated. Now we enter into the body of the inner or nested loop. Here we have a simple system.out.println statement in which the values of x and y are displayed. These two values are connected or concatenated and displayed in the output console. Having completed a cycle of the inner loop, the value of y is incremented by 1. Now the flow of the program returns to the top of the inner loop, at which point the program checks to see if y is still less than or equal to 4. Since y now has a value of 1, this statement is still true, and the process is repeated. Entering the body of the inner for loop again, x still has a value of 0 and y has a value of 1. These two values are connected, or as we say in programming, concatenated and placed in the console. Notice that because it is a print line statement, this new output goes directly below the previous output. With this cycle of the inner loop completed, the value of y is once again incremented. The flow of the program returns to the top of the inner loop, and again the value of y is checked against the condition of whether y is less than or equal to 4. Since y now has a value of 2, the condition is still true, and the inner loop is again repeated. This process continues to repeat itself with the value of y increasing by 1 each time the inner loop completes a cycle. After every cycle, the value of y is checked against the condition statement, is y less than or equal to 4. As long as this statement remains true, the cycle continues. Eventually, the value of y will become 5 and the condition statement will no longer be true. At this point, the program flow will break out of the inner loop. Now the value of x will increment by 1 and the program flow will loop back to the top of the outer loop. In the outer for statement, the value of x, now 1, will be compared to the condition statement, is x less than or equal to 4. With x now having a value of 1, this statement is true, and the program will enter into the body of the outer loop. Once again, in the body of the outer loop, the program meets the inner loop. Here, the initialized statement int y equals 0 causes the value of y to be reset to 0. And so the inner loop process repeats itself. 5 repetitions, 0, 1, 2, 3, 4 of the inner loop for every 1 repetition of the outer loop. This process will continue until x reaches a value of 5. At this point, the program will completely exit out of the entire nested for loop structure and continue on its way. The following animation will quickly cycle through the entire process to help you visualize a nested for loop structure.